Hello and welcome to aiagentstate. Today we'll be building AI automations that will help us to find LinkedIn profiles of contributors to one of the GitHub repositories. Let's say we want to hire someone with the knowledge of React. We'll go to React page on the GitHub, we'll go to the contributors, and we see a lot of profiles here. And if I start clicking through them, let's say we found Young. We know that he works at Meta and located in New York. There is an email, but there is like no LinkedIn profile. And if I want to actually go and connect with a specific person, it will take me quite a bit of time just to go through each and every profile that I see here. And by the way, I selected only like the past 2-3 years of contributions just to limit the number of people here. What if we could build AI automations that will go profile by profile, automatically scrape the information about the person name, location, company if it's available, and then also we'll go and find the LinkedIn profile for those contributors and serve us as, let's say, CSV file with all this information. That would like simplify a lot, and we'll be able to achieve our goals in minutes instead of like hours of manual work. And actually, this is exactly what we'll be doing today using Gumloop. If you are not familiar with this tool, go to gumloop.com, and they have the free pricing tier, so you'll be able to try it out without paying at all. This is pretty lengthy workflow, but just I promise that there is nothing complex. There is no code completely, and we'll go like step by step, and at the end we'll run the workflow and we'll see what type of file will be generated. So first we'll want to go and copy the URL. We have the flow basic input field, and let's say we'll paste the URL of the GitHub page with all contributors. And next we want to scrape this page. Like in order to find all the names of these folks, we'll use the web scraping tool, website scraper. We'll pass this URL to this node. As you can see, it's connected. After that, once we get the data from the scraper, we want to extract contributor name in order for us to actually go to a specific page. See, like if I go here, let's say we'll pick up some profile. The standard GitHub link to the profile is like that. So we need to scrape the name, and then we'll be able to then go profile by profile and scrape individual profiles. So we just need contributor nickname out of the whole content. And we'll actually, let me run it really quickly. I'll run the whole flow, and you will see actually how it's being executed step by step, and then we'll be able actually to see the data inside. Okay, so it's running. Let's give it a couple of seconds. Okay, it was literally, probably 1 minute at most, end to end. But now, as you can see, it generated the file, but we actually want to go and actually look at each node. So if I go to this web scraper, we can click here and it will zoom in on a specific node. And if we click on see all inputs and outputs, we actually can see all the scraped data from this node. As you can see here, this is exactly what we need to get out in order for us to go and in the next step to visit this profile and get the information like location, name, etc. That's exactly why we are using extract data, and it has pretty simple setting. So we say that we want to extract contributor name, in description GitHub contributor, type text, and then in additional context we just saying like to LLM what actually we need. You need to extract the nickname of GitHub contributors, and we provide the example in a specific format that we've seen scraper returns. And then we'll use Claude Haiku. Now, next, we need to actually, out of the just let's see what it returns. As you can see, it went on and returned us a bunch of names. Now we need to form the link. And that's exactly why we used find and replace. This is regular expression that essentially says us in the beginning of the string, replace it with the link, and then at the end, it will return as a name. So if we'll go here, this was the name. We replace the beginning of the string with github.com link, and then essentially the link is ready. One thing that I didn't mention, if you are not familiar with the Gumloop, there is a loop node. Essentially what it means is that this node will return the list of items, the list of names in this case, because we get the whole text and we are asking to extract the list here, the list of contributors. That's why it will return the list. And when we get to the find and replace, it will just loop through each individual name and will do this manipulation with the text. Next item is actually not needed if you're using it in your real use case. I'm just keeping it limited to 5 items just to save in terms of cost of running and time, because if you'll be running through thousands of contributors, obviously it will take a lot of time, but in this example, we'll keep it to 5 as an example. So it will trim the list to only 5 examples, not hundreds. And we can see the result here, 5 names. Perfect. Then we need to go to each individual URL of the profiles and scrape it. Once we scrape the profile, we also need to extract the data like name, location, company, and let's see. So scraper of the profile will return just pure, all the text that it's found on the GitHub page. But then when we extract the data, let's see what we can see here. Seattle, at Facebook, New York City. So you can play around and see what you can do in terms of location. So Facebook is a company and not actually the physical location. But company, it actually returns pretty, so Facebook, Meta, Vercel. So seems like it's working pretty well. And then the names of folks. Now the output of it will be the list of each individual like data points. So name, location, company. But now in the next step, if we want to find the LinkedIn profile, we need to be able to actually search for LinkedIn of this person. For that, we'll basically combine the name, as you can see, the name and the company into one string, and then we'll combine it also with the site LinkedIn, which tells Google to look only on the LinkedIn domain, and then we'll pass it to Google search. It's embedded node of the Gumloop. The query will be the concatenated data, and you'll be able to search for LinkedIn, and then you'll pass the name and the company. So this is the example of what we are actually searching inside the Google. So site linkedin.com, and then the name and the company. Great. After that, because it returns a list of the list, because for each result we take 2, for each search we'll take 2 results, so 2 first links, just in case if you don't get it in the first attempt. Like, sometimes it will return some generic search on LinkedIn and the actual result can be second. But you can play around and test 5 results, maybe just 1 if you're confident in the names and companies. And then so we join the list with the comma, and then we actually pass it to our CSV. This is the node that will generate the CSV file. You pass the CSV file name, you pass the name, location, company, and LinkedIn. You can use the existing file. In our case, we'll be generating the new file. And when I downloaded the file, this is the actual result. As you can see, for most of the candidates that we scraped, we were able to find the LinkedIn profile. Actually, I verified that it's pretty accurate. For some of the people, we couldn't do it. and that's fine. Imagine that you're doing it on thousands of contributors to the GitHub. This flow can save, if you're in recruiting, it probably can save you like countless hours of just manual work. And I'm showing it on the example of the GitHub, but you actually can apply the same technique, like similar flow, to any type of manual searches that you do, whether it's articles, specific articles, you want to find the authors of those, anything like that, you can do using the Gumloop or other tools like that. By the way, Gumloop has built-in LinkedIn scrapers. If you need to scrape the profile further, and let's say you want to analyze the past experience of specific candidate, you actually can do it pretty easily. You can just extend the flow that we went through today. With that, thank you for watching. Definitely subscribe if you want to see other automations that we'll be building soon. If you have any idea of automations that you need to build, maybe you don't know how, leave the comment below, and I'll try to build it next time. Thank you for watching.